Good morning, Eagles, 7th and 8th grade science. This is Mr. Mannion checking in for your May 4th packet work. You have a bit of a little outline to do, and then on the next page, which is also May 4th, you've got some questions to answer. It's not that much, it's very doable. You guys are all very smart. I know you can do it. So let's go ahead and let's jump in. All right, I'm going to get started, and we're going to read the paragraph, then I'm going to go over the main points that I think are relevant, okay? So you guys are writing these main points by hand, and you're also answering these questions, and you're sending it to email cgwsciencework@gmail.com. All right, let's get started. The rock cycle. Processes that take place on the, and remember on May 1st, we talked about igneous, sedimentary, and metamorphic rocks. And now we're talking about the rock cycle, which is all these things, all these types of rocks cycling through and becoming each other. Processes that take place on and beneath the Earth's surface can change rock. Weathering, erosion, and deposition change surface rock. Variations in temperature and pressure change rock inside Earth. At the same time, the movements of tectonic plates bring rock up to the surface and push rock down below it as well. All right? So you really only need like one, maybe 2 points for this small paragraph here. And the points are that weathering, erosion, and deposition change the surface of the Earth, and variations in temperature and pressure change rock that is underneath the Earth, right? Underneath the surface of the Earth. So that's the basis of the rock cycle. Now, the rock cycle is the continual change of rock from one kind to another. The diagram below illustrates the rock cycle. Notice the arrows and labels. They describe the conditions and processes that drive the rock cycle. Okay, so you only need 1 point for this one, obviously, because it's referring to the picture. So your point is that the rock cycle is the continual change of one type of rock to another. And then you can look here at the picture, please, and you can see things changing. And you had this on one of your worksheets from the last packet, but you can see that igneous rock breaks down to sediments, which compact together to form sedimentary rock, right? And then those get heated and pressurized to form metamorphic rock. And then the metamorphic rock melts, turns into magma, and then hardens up into igneous rock. See, it's all a cycle, and all of these rocks are becoming one another as time passes, and some rock may be a sedimentary rock, and then it can turn into an igneous rock and turn into a metamorphic, and then years later it might become a sedimentary rock again. Who knows? It might have some new pieces of rock with it. So let's go to this next paragraph here. Any of the three major types of rock can change into one of the other types. Notice that the rock cycle includes many different pathways. For example, heat and pressure can change igneous rock into metamorphic rock. Igneous rock can also be broken down to become sediment, which can form sedimentary rock. Sedimentary rock can change into metamorphic rock or igneous rock. Some of these changes happen quickly, as when lava hardens after a volcanic eruption, but most happen very slowly, as when sedimentary rock excuse me. Most happen very slowly, as when sedimentary rock forms over millions of years. So this little paragraph you should have 2 to 3 main points for, and you should see that the rock cycle has these arrows in it that are going across, right? They're going across the circle. That's because it's not just moving in a circle. Any rock type can become any other rock type, right? An igneous rock can break down into sediments and become a sedimentary rock, or it can get melted and pressurized under the earth and become a metamorphic rock. Or an igneous rock can simply melt again and then become an igneous rock again, right? It can melt back into the lava, be erupted from the volcano again, and then cool again, becoming an igneous rock again. So that is the points there. I'm going to let you guys sort of use that information to make those points. Think about what is relevant here. We're talking about how the rock cycle is not always a circle, okay? Sometimes one rock can become two different kinds of rocks even. All right? So let's go on to these questions here for May 4th. Now remember we talked about chemical weathering being weathering that takes place and changes the rock that is being weathered to become a new kind of rock. There's a chemical reaction happening. And mechanical weathering is something that just happens when one rock is broken down into smaller pieces of the same kind of rock. It's a physical change and not a chemical change, okay? Which of these is an example of chemical weathering? A. Plants wedge their roots into cracks in rock and push it apart. That is physical weathering because plants pushing a rock apart is purely a physical force moving the rock. It's not a chemical change in the rock. B. Acid rainwater seeps into the ground and dissolves limestone. Well, the key word here is that it's acid, all right? And we read and we talked about how acid is corrosive and it can cause minerals to break down and become new substances, new rocks. So if acid is breaking down limestone, then that is a chemical change. That is going to be creating a new substance from the interaction of two old substances. So we know that's a chemical change. So that is our best candidate for the answer right there, B. C, gravitational force pulls rocks to the bottom of a mountain. That's C, just physical force. Gravitational pull, there's no chemicals involved, so that's just physical. D, rock pieces carried by river water wear away pieces of rock in the riverbed. So this is, again, rocks hitting rocks, and it's just physical. It's not chemical. So the answer is B, acid dissolves limestone, and that is chemical. Anything where an acid is dissolving a rock or a metal, that is going to be a chemical reaction because the acid has these hydrogen molecules that like to bind to lots of stuff and tear it apart. All right, so let's go to number 2. What does erosion do? Now we just read all about erosion. We know that erosion carries sediment from one place to another. It carries it from one place to another. So does erosion A change rock chemically? No, it does not. Does erosion B changes rock particles into rock? No, that's not erosion. That's cementation. C, it breaks down rock physically? No, that's weathering. Or D, it moves pieces of rock. The answer is D. Erosion moves pieces of rock. Number 3, deposition is a process that A, dissolves sediment, B, breaks down rock. No, that's weathering. C, drops sediment. Or D, moves rock particles. Now the answer is C. Deposition drops the rock. It deposits it in a new place. So deposition is C, drops sediment. Okay? Now, those were pretty easy. I know you guys did this and did a good job. Thanks for watching, everybody. Keep doing your work the best you can. Remember, please email that work to cgwsciencework@gmail.com. Remember, sending in your physical packet is a last resort. All right. Hope everybody's doing well and have a great day.